welcome all. Welcome to our next session in highway engineering. So this will be a chapter 1. So we are going to see, as I told you earlier, this will be some least important topic anyhow. So anyhow, we have to give this introduction compared to an exam point of view. So if you see geometry design chapter will be the highly important chapter in this total highway engineering, and also this highway materials is least important, but little more important than the history and survey chapter, and the design of pavements is furthermore equally important as similar to the geometry design. So anyhow, so we are in the chapter 1, history and alignments. Okay, history, we will see some history of roads from where we started and where we are now. Okay, so the chapter 1 is history of roads. First we will see across the globe, what was the story across the globe. So if you see, you are seeing the figure Roman roads. The humans were initially started walking by, if you remember, they usually very ancient civilization they started by food. Okay, so which lead them to the campsite for food, for streams of drinking water, etc. So next they used animals. If you remember, they started using animals for luggage carriers. Okay, so then when there was an invention of wheels, if you remember, there was invention of wheel is the first classic invention which changed the total world. So then the animal drawn vehicles came, and because of the animal drawn vehicles, the road surface which they were using for walking were not capable of taking that greater loads. If you remember, thus they need a harder road surface. Okay, so to provide adequate strength, etc. So if you see, that's why the Roman roads, which was the Romans, if you remember the word, Romans were the pioneer in road construction, is a very common term you would have heard. So they were the first people recorded to introduce roads with the hard surface for the animal drawn vehicles. Okay, for as I told you, for the wheel invention, it is, if you see, it is approximately, although you remember the ancient civilization was very old, like 3500 BC, the recorded roads were around 300 BC, like something like what, 2300 years ago. You see the figure. So they have a curbstone which divide the, you can see the curbstone which divide the road area with respect to the remaining areas, like it's this will be considered as a shoulder. We will see that in detail later. And Roman roads have heavy stones at the top and heavy stones at the bottom, and they have a filled stones. This is a lime concrete. You can see they have filled with the lime concrete and some broken stones in between, and you see the total thickness is 0.75 to 1.2 meter. Even nowadays we are providing this much, even for a heavy truck and for a flexible pavement, still we are providing this 0.75 to 1.2 meter road. So if you see, they have provided a very good foundation and very heavy thickness for a road for a very small load of animal drawn vehicles. You understood, like even a 2300 years ago, so they have a similar foundation thickness, which similar to us after 2300 years ago, we are also using approximately the same amount of thickness. Okay, even our national highway will be approximately only this thickness. So thickness wise it is okay, but if you see, they have very heavy stones at the top and heavy stones at the bottom, and you see there was no this regardless of gradients, means they didn't have any type of gradient or slope to be provided. So the problem of rainwater, I hope you understood. Okay, so there is no gradient, means the rainwater stays over the top, and this will create a huge mess. So this was the first initial recorded road they have seen, Roman roads. Okay, and you should remember the 2 points, the gradient was not there, and there was a heavy foundation stones at the top and bottom, and in between they have filled with this stones as shown in the figure. Okay, you can pause the video and draw the figure if you are really interested to know the history. And next, the very famous thing happened after 2000 years approximately, after the Roman roads were recorded. You see, approximately after 2000 years, this Trusgut is a French engineer. He made a small revolution. You can see the difference in the figure. There was no stone at the top, there was no heavy stone at the top, and approximately they have some camber. Camber is like a gradient. Okay, gradient at the center line, and they have a shoulder slope and they have a side drain also. Okay, so the major difference between like Roman roads and Trusgut is, so he didn't use the heavy stones at the surface, and he used a very small stones. You can see the stones he used is very small stones, and the thickness of the road he reduced to only 30 centimeters required. Okay, So in the order of 30 centimeters, sorry. So he reduced the overall thickness of the road, and he introduced the broken stones in between, and he removed the foundation stones at the top. Okay, so this was the two difference you should know. Trusgate, what he made from Roman roads is he removed the top surface foundation stones, and he considered subgrade and drainage of the surface water. You can see this, they have provided a slope something like this, so that the rainwater will drain away, and there is a side drain to collect the drainage water. So this is the two major idea he developed. Still, the finally in our, even in our roads, some of the idea from Trusgate we are following, even in our world class roads, like even not only from India and also for other countries, still they are following the such type of drainages and side drain, everything we are following from the Trusgate, who introduced in 1700. Okay, so this is the extra difference you should know from how from Roman roads the Trusgate has improved. Okay, so next another guy called Telford, he was also a similar engineer during the same time of Trusgate, but he is a Scottish engineer. You see, what he introduced is like a layer of aggregates. Okay, so there was no layer being formed initially, it was just a filling of rocks, but he introduced a layer of aggregates first, and he has a level subgrade. You can see it's a straight line, but he has a similar gradient introduced by the Trusgate. So subgrade is level, you can see the subgrade is very level, and but at the top they have maintained a slope of 1:45 for the drainage purpose. So this, and he introduced a layer of aggregates, that's what you should see, and he has a very heavy foundation stone of, you can see 17 centimeter at the edges, very small stone, to very high stone at the center. You can see 22 centimeter thick stone at the center. Okay, so and he has introduced a total width of the road with approximately 9 meter, and you should remember three things in the Telford construction. Okay, so he introduced a layer of aggregates, first 40 mm, second 50 mm, third 100 mm, and 180 mm, and this 180 mm in an average 17 centimeter, like 170 at the edges and 220 at the center. So he introduced a layer of aggregates, although he maintained the same gradient suggested by the Trusgate. Okay, so this is the Telford construction. Still we are in the same period of Trusgate. Finally the man came, Macadam. So he collected all the ideas of everybody who were the people who did before, and Macadam is around, I think he is around 1800. He came after Telford and Trusgate. I am thinking of the year. Okay, I didn't remember. So anyhow, so this Macadam, what he introduced is he collected all the ideas whatever I said. Okay, so this is the road, you can see the right side road, and still after Macadam used this idea, developed idea, I will discuss this idea in a minute. So Macadam developed his idea, and the British followed the same idea. Wherever British occupied countries are there around the globe, like India, Sri Lanka, Australia, Malaysia, everywhere, so wherever the British occupied places were there, everywhere they planted this Macadam idea of construction of road. So in India still we are following the Macadam type of construction, and it is been widely accepted across the globe. Okay, you see whatever what is the major thing he has done? Heavy foundations were neglected. You see, you can see the figure, the heavy foundations were a main thing in Trusgate and Telford construction, but he found that heavy foundation will not make any big difference. Okay, we don't need such heavy foundations in the road. So what he introduced, you can see the layer of rocks. So first layer is you can see he introduced 20 mm aggregates. This is 20 mm, this is 37.5 mm. You can visualize, right? It's just 2 centimeter, 3 centimeter aggregates up to 50 mm aggregates. He introduced this concept. This economically was very feasible for anybody, because you consider a country like India who need to construct a foundation with foundation stones, heavy foundation stones, it will be very, very expensive. So his idea was widely accepted, and he also has a cross slope both in, not only if you remember Telford, what he did, he has a straight, you can see here, he has a subgrade of straight line, but in Macadam he has a slope, you can see subgrade also has a slope of 1 in 36, and this slope also has a slope of 1 in 36. Veering course also has a slope of 1 in 36. Okay, this is the veering course. So he has maintained a good slope to have it for the drainage purpose, and also he maintained a aggregate layer as maintained by Telford, Okay, so and he removed the foundation stones. So this was a major breakthrough, and still there small changes will be there. We are not using a 50 aggregates nowadays, and there are small changes. I hope we will see the design of flexible pavements in the chapter when it is coming, but we are following the macadam type of construction. Okay, so you see, as a final conclusion, I wish to compare something. You see, I introduced from Roman roads. Truscott removed the top layer. I hope you remember, he removed the top layer of heavy foundations. And you see, Telford introduced the idea of small thickness at the edges and improving thickness up to the center, and small thickness again going to the center. But everybody has introduced, you can see the gradient, everybody has introduced. Macadam removed that bottom layer. There is no foundation stones at all at the bottom, and he has a good slope, like 1 in 45 was followed by Telford. Here everybody he recommended a slope of 1 in 36. Okay, camber. This is the three major difference. This is how the history came. Okay, I hope you know the name Roman roads. From there, how Truscott came, then how Telford has modified a little from Truscott, then how Macadam took their points and made world class roads. Still we are following after 200 years also. Okay, so this is how the world history ends, and now we are having a modern roads. As I told you, we follow a macadam type of construction, and macadam type of construction has been improved a lot from industrial age to information age, because we are having a more modern construction equipments. Initial days, if they took 1 month to put 1 kilometer of road, we are nowadays they are putting only within 3 or 4 days. No, I am telling about overall setting. Okay, so this is the modern roads what we are having now. You can see the right side, from Roman roads to French roads, French road to Scottish roads, Scottish roads to British roads. British roads has been introduced across the modern roads. In the modern roads, there are two type of roads: flexible pavement and rigid pavement. Flexible pavement is nothing but, we'll see in detail when the chapter 4 design pavement comes. Any flexible pavement is your bitumen road. Wherever you are seeing a bitumen road outside of your home is a flexible pavement, and the rigid pavement is nothing but a concrete road. Okay, you can see first layer will be a, you can pause the video and clearly see that for 2 minutes. You should try to understand what is surface dressing, what is surface course, what is base course. Those things are not in there, not there in rigid pavement, because everything is covered as a concrete slab. But subbase is common for both, and formation level and the natural formation. Natural formation is soil, they have a formation level, then they have a subbase, and the concrete road is laid. So concrete road does not need surface dressing, surface course, base course. It is like just a slab. Okay, like how your house has a concrete slab, similar to that your rigid pavement will have a slab. But in flexible pavement we will have a layer by layer of aggregates. Okay, surface dressing, surface course, base course, etc. Okay, so this is how the modern roads came, and we are nowadays we are having a flexible pavement and rigid pavement. This how to design this two we will see in the chapter 4. Okay, I hope you understood the world history. I will tell you about little bit about this history in India, not in detail, in short. Okay, so in our India, the oldest recorded road, how the road should be laid, is given in Arthasastra. I hope you remember Chanakya. So Chanakya has written Arthasastra for Chandragupta Maurya to how to rule a country, right? I hope you know what is Arthasastra. In that they have given a chapter separately for roads. Okay, how a king should access his villages. So first, how the different types of roads should be there, war roads should be there, how the escape routes should be there. Everything he has discussed. That was the oldest record. It is also approximately around 2300 years ago. If you remember, so this books was written 2300 years ago, means approximately during the Roman period. Okay, so if you see, when the Roman was laying the roads, already we also have a plan of there was roads. This is the recorded history in ours. Okay, but it was not as famous because Italians were ruling the world that time. But India was very small, only in the area of northern part, right? There was no India at all first. So I don't know why it was not so much famous, but as per my knowledge, both were the same time. When Chanakya was writing this Arthasastra, were Chanakya living time, that time only the Roman roads were also recorded. Okay, then the step 2, how the Mughals were the pioneer in road network. Okay, so when Mughals were collectively making India as a coming under a single unit, If you remember, Mughal started from Afghanistan, Pakistan to Delhi, keeping Delhi as a capital. They merged Rajasthan with Rajputs, everybody, and they tried to merge left and right, and also they reached up to the bottom. Like I hear the stories about during Khilji period, they reached up to Madurai. It's like the southernmost part of the India. So they have a connectivity everywhere. So when everybody was coming under Mughal's rule, to reach the king to go everywhere, so they have a good road network. So Mughals developed the road network, at least like a, not like a flexible or rigid pavement, at least like a hard road surface. And then when the British captured, and the British introduced the railways, if you remember, and the railways become the pioneer of mobile transport to transfer everybody. So for the then the roads were, during that time, the roads were just a feeding stuffs for railways. Okay, railways was the main network. Second only the road was there. But after the First World War, there was a great collapse of all the roads because of the movement of all the war vehicles in our country. So all the roads were heavily damaged. Okay, and also because of the introduction of motor cars, they need a good roads to have a better connectivity. So the British formed a road development committee after the First World War. You can see exactly like after 10 years after the First World War, they have introduced a committee. They asked to improve the road. This is the first committee introduced for our country for the concern of roads. Okay, there was nothing before. It was under the name called Mr. JAYAKAR. So they introduced the first road development committee. So during this committee meeting under JAYAKAR, so they have classified these recommendations. Still this recommendations has been followed across our country. Okay, so the first concern was the road was considered as a national interest. So national interest means all the roads across the country will come under central government, and no local body can take care of the road. Like if you remember the olden days, they will have a check post for each village. The road cannot be used for this type of people, this type of people, and those people has to pay something for using that road, correct? So that was totally boycotted, and the total roads, all the roads across the country was coming under a central government, and he has committed to develop a 20-year old road development plan. How our Indian politics has a 5-year plan, like every 5 years we vote. Similarly for the roads, they had a 20-year road development plan. For every 20 years they decided to meet and discuss the improvement of what happened in the past 20 years and how to improve the next 20 years. So then the third recommendation was they introduced a semi-official technical body called IRC, like how you have for in RCC and steel, how you have IS 456 and IS 800. Similarly, they had a formation of semi-official technical body. Understood? So they form the rules, they form all the committees. So like some head of the department. JAYAKAR was not a head of the department, right? Anyhow, this is the recommendations by the JAYAKAR. So they recommended they need a technical body to take care of the road. So they introduced the IRC, and it was formed after 7 years after the JAYAKAR committee meeting decision. Okay, after 7 years in 1934 they formed IRC. Now even now after 100 years almost, everything across the road was coming under this IRC. Okay, all the even in the syllabus, if you see GATE syllabus, you can see that term IRC codebook were really used. This was recommended by JAYAKAR in 1927. And then to conduct everything separately related to road, we cannot go to the government every time, so we need separate funding. That was another suggestion. So they started collecting fund under Central Road Fund. After 2 years of JAYAKAR committee decision, they started collecting fund for like license fees, road taxes, whatever you are paying, and also for petrol and diesel. For every petrol and diesel, IRC will get 1 rupee nowadays. I think 1998 they will take per liter 1 rupee. If you put 70 rupees, I think nowadays 70 rupees if you pay to get 1 liter of petrol, 1 rupee will be going to the IRC. So similarly, they have in 1929, I think they were collecting 20 paise to 25 paise per liter they were collecting. So this is how the Central Road Fund is found. For everything, if you are paying a license fees, LLR fees, everything, some portion of money is going to the Central Road Fund, which is used for paying the people. Okay, paying to the people who are working in this under the road. Next suggestion by the JAYAKAR was separate research organization for the road. Okay, so somebody should sit and do the research pertaining to the roads. So all the modern equipments or techniques happening across the world will be researched under them, and they will suggest modern equipments to our workers, so that we will be keeping up to date. We cannot even only follow 1940s rule or 30s rule, right? It was a very good suggestion. So they have introduced under Nehru CRRI, Central Road Research Institute, in 1950. Similarly, if you see another suggestion I should tell you, there are some other research centers for civil engineering. You can join MTech or PhD, which is coming under Council of Scientific and Industrial Research. Okay, so Council of Scientific and Industrial Research is a research center. So if you want to become scientist in this field, SCRC is a Structural Engineering Research Center in Chennai. CBR is a Central Board Research, Central Building and Road Research, Central Building Research Institute. CRI is a Central Road Research Institute. So there are 3 research centers. If you wish, you can join MTech and PhD in that also. You can Google, you will get more details. Okay, one of that research center was formed in 1950, which was suggested by a JAYAKAR in 1927. So hopefully if somebody joins, thanks to the JAYAKAR. Okay, so these are the 5 recommendations, and this 20-year road development is very famous, and even still we follows the same. Okay, so if you see in depth of the 20-year road development plan, after the JAYAKAR committee, the first 20-year road development plan, as per the plan, they met in Nagpur in 1943, and they planned for the next 20 years. So they planned first, they in that plan, meeting, they have, you can pause the video and note this point. These are very important points, whatever happens in the, so I have given a details of 3 plans. First, they have sat in 1943 in Nagpur, and they decided the roads will be classified as national highway, state highway, major district road, other district road, and village roads. That was their first suggestion. Okay, so they classified national highways are different, connecting the national integrity top, and state highways, what is state highway, and what are the major district roads, how to define other district roads, and how to define the village roads. Okay, and the second target, what they targeted for next 20 years was, they planned 2 lakh kilometers of the road. At least there should be a 2 lakh kilometers of the road, and they decided star and grid pattern. Okay, I will show you in after 2-3 slides. You will see the photos of what is the star and grid pattern. Anyhow, they decided this star and grid pattern will be your will be the pattern followed while constructing the new roads. Okay, and they have a target of at least 16 kilometers of the road should be there. At least 16 kilometers road should be there for every 100 kilometer square. If you take a 100 kilometer square of an area, at least a 16 kilometer square road should be there. That's the density. Okay, it's a density, but how you know, kg per meter cube, right? Similarly, how much length of the road per kilometer square. Okay, so for every 100 kilometer square, 16 kilometers should be the road should be there. That's what their target. These targets were achieved, I think, approximately in 18 years itself. So they met in second time. You can see they met at next 18 years itself in 1961 in Bombay. That was the second 20-year road development plan. Okay, so since all those things were achieved, whatever the target was achieved, they moved to the next target of 10 lakhs kilometer of the road. 10 lakhs kilometer of the road across the country, and they decided the density should increase from 16 kilometer to 32 kilometer per 100 kilometer square. Okay, and also they decided 40% of the length of the road should be surfaced. I hope you know surfaced means like a flexible pavement. Now you have for national highway, right? So in that total 10 lakh kilometers, approximately 40% of the length should be surfaced, and they decided of constructing 600 kilometer of expressways. Expressways means, I hope you know, like 120 to 160 kilometer per hour of speed vehicles will travel without putting any brake. There should not be any speed breaker, and it should be allowed freely movement. So construction of that expressway should be there. I think connecting Delhi to Mumbai to Pune, something many roads were they were targeting, because so, and also they decided there should be a separate traffic engineering cell should be there for every state. Each state, like Kerala, Tamil Nadu, everywhere, every state should have a separate traffic engineering cells. So these were their targets, and almost everything was achieved. So then they meet after the next 20 year in Lucknow. Okay, so this is the final, I think so. This was finally recorded 20-year road development plan, and in this case, they in 1981 they classified the road in little different way, like a primary, secondary, and tertiary system, because they want to introduce expressway inside the road classification. So they changed the classification as primary, secondary, and tertiary. Under primary, if you see, they have expressway and national highway. Under secondary, they have state highways and MDR, ODR, and VR. Okay, only difference is they have a expressway included. and then this is road actually. So and then their target improved from, you see, 27 lakh kilometer, okay, and the density is improved from 32. The last 20 years was 1961 to 81, they have target of 32. Now they decided for 82 kilometer per 100 kilometer square, and national kilometer should form a square grid of, everywhere if you see, they should form a square grid of 100 kilometer cross 100 kilometer. Okay, this is what they have planned. It should be something like this, square grid of 100 kilometer cross 100 kilometer. And see, if you can refer the book, they have other suggestions also. If you see Lucknow plan, there will be some 16 suggestions will be there. So if whatever important I have given you here, what is the main thing, what is their target, okay, whether for every plan I have showed you what is their target, what they achieved, what is their target, what they achieved. Okay, so if you want more suggestions, you can see the textbooks. Kanna and Gusto book is there always, so that is like a bible of our transportation engineering. You can refer that book if you want more details. Okay, so this is what important for your exam. Okay, so under Lucknow plan, they have given also formulas to estimate how much should be the length of the road. Okay, so you see, remember I wish to tell you again, following are the formulas coming from the Lucknow last 20-year road development plan. Lucknow plan, they have given the formulas for different classes, how to determine the length of national highway is approximately, you put the area, consider like a Tamil Nadu or Kerala, you know the total area of Kerala, you just put the area of the Kerala there, you will know how much length of the national highway should be there, and you put area here for this formula. This is the formula for area by 25 is the formula for length of the state highway, or if you know the number of towns in that in that area, so you can even put that formula 62.5 into number of towns minus a by 50. Similarly, the third formula, if you see, you can put a by 12.5 or 90 into number of towns. Fourth formula, total road. Okay, what should be the total road in length is 4.74 into number of villages and town inside that area. Okay, so what is the rural road? Rural road means in the total road, you take the total road, separate all other roads, you will get the rural road is very rural roads. Okay, what will be the, like something like a local village roads, in between, very rural roads. Okay, I hope you know the English, like very rural roads, that length also they have given a formula to calculate. Understood? So they have given a formula. Again, I will revise this one, please listen. They have given a formulas from the Lucknow road development plan to estimate based on an area. The first plan is based on length of the national highway is area by 50, length of state highway is area by 25, area should be in kilometer square. Okay, or 62.5 into number of towns minus a by 50. Length of major district road is area by 12.5 or 90 into number of towns. Total road length is 4.74 into number of villages and town. So, okay, I will show with an example. I will be solving example in few minutes. You will come to know how to use these formulas. Okay, so these are the different road patterns. You see how to, if a city or a town doesn't have, or you are planning a town planning, if you are planning a town and there was no town at all, okay, we can introduce the towns like this. Okay, the step 1 in town planning is how you planning a road network. So if you see, either you can have a radial or star, you can see the central business point is somewhere here. Okay, so this is a radial or star or circular pattern. This is radial or star and grid pattern. See, radial or star and circular pattern. Again radial or star and grid pattern in the form of grids. Rectangular or block pattern, hexagonal pattern, or radial or star and block pattern. Okay, so this you should know. This is very, maybe it will confuse you. These are the three different terms. Radial or star is common. You can see this is also, this also, this also, everything is same. Only difference is circular pattern, grid pattern, and block pattern. Okay, so these are the different types of road patterns you can plan when you are doing a town planning. They have introduced in Chandigarh. If you see a Chandigarh, you can Google it. So this was a well planned city in India. So they have a rectangular block pattern. If you see an address in a Chandigarh, there will be it will be named under sectors, and also in the every street will be named with in the terms of sector 2, 56, 26, something like that. Okay, so this is a well planned city. Example for rectangular block pattern is Chandigarh. Radial and circular pattern is Connaught Place in New Delhi. You can Google map it and see how it looks. It will be something looking like how I showed in the figure. And if you remember, I told you in Nagpur plan, first road 20-year road development plan, all the roads in the countries were planned in star and grid pattern. Star and grid pattern, you can see something like this. So this were the target by the first 20-year road development plan. Okay. So I have given you some inputs. You can use it if somewhere required. These are the different types of road patterns. Okay. 1 second. So these are okay. So if you see an alignment, you should know some other one more points also. If they are asking like in the theory part, alignment means nothing but we have to fix a center line of the road. That will be your step 1 actually. So how will you? It should be always short. The center line should be always short, and it will be easy to lay, and also it should be safe, and it should be economical while connecting the cities. Factors controlling is obligatory points. Obviously, what are the obligatory points we should match, and how the traffic will be, and the geometry design, and the economy. So these are the 4 different factors which will change course your alignment. Okay, I hope you know how the traffic will affect. Okay, heavy traffic you have, obviously you should need to align at different places. And if you see the geometry design, something like side distance, super elevation, if we are facing some bridges across the road, so you should consider that changes also in your alignment. Also the economic factor, obviously how much money has been allotted, whether to include yourself with 5 bridges or 6 bridges or something like that. You should, based on those factors also, your alignment will change. Okay, so I hope you made you clear. If somebody asks you what are the factors, you can use these points. Next, if you see what are the engineering surveys you should take. So first, what are the these are the different stages of doing an engineering survey before laying a roads. Okay, first it's like fixing a highway location, whether the road has to go by this way or not. The step 1 was to study the map study. Okay, so you take the city map and then you do that. What are the like if you have a town A and if you have a town B, you study all the possible routes which can go from town A to town B. Okay, I will take the total map and then I will do the several possibilities. I will do the reconnaissance survey, then I will do the preliminary survey. What are the possible every survey has some more meaning actually. So if you go in depth, you can use the textbook to study. Preliminary survey will decide final traffic locations, and they will do the OD survey, origin and destination survey. Finally, we will have which one has more saturation points, like a usage factor. Okay, consider if the town each road is 1, 2, 3. Second road will be used by 70% of people for both industry and agricultural goods transfer, and these many villages will be connected. If you choose road 1, these are the things will happen. If you road 3, these things will happen. This will be our conclusion, and finally you will fix which is the perfect one. Okay, which is more people getting used, like a road 2 or road 3 or something. We will use that final location and detail survey, and we will fix the final survey. And what are the drawings you will use is, if you see a term called key map, it is nothing but it shows the proposed and already existing road and important places to be connected. So as I showed you here, A and B is there, right? So whether the road, if you choose road 1, you should connect some temple is here, some mosque is here, something and all there, then before going to B. Okay, you cannot skip these points, right? So what are the key points you should consider in the map? Those things will be covered under key map. Index map means it will show the topography of the area. There is a river, there is a hills, there is a plateau, there is up and down, everything will be showed under the index map. Okay, so from this slide I hope you should know 2 different map names, and you can Google these maps to see what does it really show, and different stages of survey they will do, and different factors controlling your alignment, etc. Okay, so some other 1 marks. Okay, this is one of the GATE 2007 question. They asked what is golden quadrilateral, what are the cities it is connecting. Golden quadrilateral, it is connecting from I hope you know Delhi, it is Kolkata is here, and it is Chennai here, and it is Mumbai here. So golden quadrilateral is, they are framed under this project, they are connecting these 4 cities. Okay, so this is the golden quadrilateral project. North and south corridor is, they are connecting from Srinagar to Kanyakumari. East west corridor is, they are connecting Silchar in Assam to the Port Bandar in Gujarat. Okay, and they have other port connectivity projects also. So One of the other one mark they asked is, which is the largest national highway? So the largest national highway is NH7, which is coming from Varanasi to Kanyakumari. Okay, if they asked in 1 mark, and you should know also NH1, NH2 plus. Please Google those things. NH1 is nothing but they reach up to, I think, up to, then there is one more NH1A is there. NH1 was extended to Jammu, I think, to 1A. You can see where from Delhi to Amritsar, I think. You can Google it, I still remember. Delhi to Amritsar. Then they extend it to some other place for NH1A. So you should know these things, NH1. And in front of you, whatever NH is passing in either in Kerala, Tamil Nadu, anywhere, whatever NH is passing, please you should know those knowledge also. Because this type of question also has been asked, NH7, where it is connecting, all those things. Okay. And you should be updated with your newspapers, what are the projects has been signed under this one, because all these things has been really asked in this IES general type question. Even in GATE questions they are asking what is currently being very famous. This golden quadrilateral was very famous, so only they were asked in GATE questions. Okay, give me a second. So we will solve some problems to understand whatever we have discussed. So as per 1981 census, means as per the Lucknow plan, they have given the area. See, Maharashtra's area they have given. Okay, and number of towns in Maharashtra above population 5,000 is given as 567. Total number of towns and villages also they have given 35,778. So they asked you to determine the length of various road categories. You can pause the video and solve yourself, and then you can compare. Anyway, you see how practical it is. They have given the total area of the state, and they have given the number of towns in that area, and they are asking you to determine the length. So I hope you remember step 1 is to, since the area is already given in kilometer square, you can directly use it, or some problems they will give you in hectares. Okay, so if they have given in hectares, you have to convert into kilometer square, because hectare itself is an area. Okay, so you have to convert into a kilometer square before using it. Okay, so here anyhow the problem is given directly in kilometer square, so directly substitute. Area by 50 is 6,160 kilometer. Okay, that's very good. So in Maharashtra, at least as per the Lucknow plan, 6,000 kilometer of national highway should be there. State highway, you see, I used the first equation here, second equation here. So as per area divided by 25, approximately 12,000 kilometers should be there. Using the number of towns formula, at least 29,000 kilometers should be there for a state highway. Even for major district road, I hope you have two formulas, right? One formula is for area by 12.5, that will give you 24,640 kilometer. 90 into number of towns. If you remember, I have given a formula, 90 into number of towns, that will give you 51,000 kilometer. And length of the total roads, you can see these are the steps I followed. So length of the total road, I have given a formula 4.74 into number of towns and villages. So 4.74 into 35,000 was given in the question. So total length of the road should be approximately 1 lakh kilometer, 1,69,587 kilometer. So length of the rural road, just you take this one, length of the road, and subtract all other roads, which will give you the remaining roads. Understood? I have taken this one. You see, length of the rural road is nothing but take the total length of the road, subtract the values of okay, so you should subtract the values of, you see, I think 24,640 plus, because MDR cannot be a rural road anyhow, and state highway cannot be a rural road. So subtracting these values, I think so, this will give you this value. Okay, is it correct? 43, 24 plus 630, 43. Yes. So I have taken, mentioned here, right? I have taken the first two formula values. If you take second formula values, length of the rural road will come down a little lesser. Okay, so I hope I made you clear how to use these formulas. So if you have any doubt, please ask me. But this is a standard procedure. Step 1, find the national highway. Step 2, find the state highway based on two formulas. Step 3, find the major district road length based on two formulas. Step 4, find the total length of the road is equal to 4.74. You will get the total length of the road. Subtracting these values, national highway, state highway and MDR values, you will get the remaining length of the rural roads. Okay. So question 2. So there are three roads. You can see P, Q and R. There are three roads they have planned. It's like if you see, there is a town A, again there is a town B. So they have given a details of three roads, P, Q and R. They have given the roads of three roads, and you see the road P will have approximately length 20, and it is connecting a village with a population less than 8 with village with a population less 6, 2000 to 5000. Number of villages connecting is 6. 1 greater than 5000 population villages it is connecting is 1. So similarly they have given details for P, Q and R. Which is the best road? Practical question, right? Which is the best road? P, Q, R. Or you give it in the order of priority. That's what they are asking. Okay, you can pause the video and solve yourself. Hint I will give you is a you should have idea of saturation unit. This term you should know to solve this problem. Anyhow, if you don't know, please come to answer, or you can pause and solve yourself. You see, when the village population is less than 2000, I assumed utility. This is the given, right? Totally less than 2000 population people are there. 2000 to 5000 villages are there. Greater than 5000 villages are there. Obviously, people with less than 2000 will use the road less compared to 2000 to 5000 and less compared to greater than 5000. So this utility value you should devise yourself, or you can use this as a standard value. You can put any value, but remember, less than 2000 people, obviously they will use less. I have 2000 people. I will consider I am using the road. Consider 3000 people are there. They will use little more, right? Little more is I use the term 2, and obviously 5000 plus people will use the road little more high. So I used the term 3. So using this terms, you can see I used this. 8 is the number of people with population less than 2000. So I used the utility factor 1. For this second population I used 3. Third population divided by the length of the road will give you answer per kilometer. Correct? Per kilometer, what is the utility of each road? So seeing the answer, you can see R will be, the road R will be having 1.92, means people, if you put the road R, the people will be using 1.92 times. Okay, the utility will be 1.92 per kilometer. So R is utilized very high compared to Q, compared to P. So this is how I came. Okay, there is no formula. What I did is, for each village population I just multiplied by the utility factor and divided by the total length of the road. So this was I did for everything, and which is the highest number will be your answer. Okay, because they utilized more. This is just a practical question. There is no formula here. Remember, it is just a aptitude question and with a more common sense. Okay, so this is, I will give you one more question as an assignment for you. Here I have given added one extra term called industrial product. Okay, you can take utility factor for industrial product approximately 10. Okay, because you can assume something like this: for 1000 to 2001, 2000 to 5002, 5000 to 10003, greater than 10004, industrial product approximately 10. Using this way, again you divide by the total length of the road, then you will have your own priority of roads. Okay, which road is better, which road is bad, and which you will suggest. Okay, in I think one more GATE exam, they have also had agricultural products. So in GATE exam or any type of exam, if they keep on giving some extra things, you should have your own common sense. Compared to industrial product, agriculture product will be very less, right? Very less heavy. So in that case, when I am solving problems, I will use a common factor of 1 for agricultural products. Okay, so leaving that, you don't need to think about that now. You try to solve this problem, whatever is given here, and I will update the answer in the next session. Next video you can see for the answer for this. Not for a key, I am not going to solve, just you have to multiply and divide the answer like how we did for the question number 2. So I will tell you the answer anyhow in the next session. Okay, so with this we are completing the chapter 1. If you have any suggestion, or if you want to more details of any topic, please let me know. And since it is least important topic in the overall transportation engineering, I try to cover in and around everything, but in chapter 2 the geometry design will be covered in very detail. So come with the brisk mindset for the chapter 2. Okay, thank you.